Good morning, everyone. I am Dr. Surangani Bandara from Sabaragamuwa University of Sri Lanka. Today, I would like to talk about the characteristic of landslide induced by the 2004 Mid Niigata Prefecture Earthquake in Japan. This research work carried out in 2017 under the supervision of Professor Ohtsuka Satoru from Nagaoka University of Technology. Let me move to the flow of my presentation. During this presentation, I would like to talk about the objectives, and after that, I will move on to the background of this study, and then I will talk about the landslide distribution around the central area, and after that, I will talk about correlation between causative factors and landslide. Finally, I would like to conclude my results. So, as you all know, Japan is a seismically active island nation, and the country has long been at risk of earthquake and related disasters due to its geological location. So, earthquake can be identified as one of the main triggering factor of many types of hazards, as ground shaking, such as ground shaking, surface faulting, landsliding, liquefaction, even tsunamis. Among these, landslide can be identified as one of a disastrous geohazard because they usually occur suddenly and destroying critical infrastructures and ecological systems, as well as cause human casualties and economic losses. So studying on the causative factors for landslide, which are triggered by an earthquake, is an essential subject for understanding which area could be more prone to landslide in future earthquake. And if you talk about the Mid Niigata Prefecture Prefecture earthquake in Japan that was happened in 2004 on 23rd of October. And so in addition to the main shock, you can see from this table, there are other three aftershocks that has depth, that has magnitude more than 6. So I think you can imagine like how it damaged the around the epicentral area by looking at this earthquake sequence. So, and you can see in the figure 1, I have captured here the location of the epicenter. And so, despite the moderate size of the landslide, more than 5,000 of landslide occurred around this central area. Here in this figure, you can see the most destructive, one of the most destructive landslide called Higashitakisawa landslide, and also in the next slide, this one, in figure 3 and 4, you can see other two types, two most destructive landslides, which are called Terrano landslide and Dainichi landslide. The largest landslide in area and volume triggered by the earthquake was the Dainichi landslide. And apart from that, the catastrophic earthquake caused extensive damage in the central area, Ojiya City, Nagaoka City, where I lived in Japan, and Yamakoshi village. And you can see it on the figure 5. So these are the data sources that I have used in this research work. And now let me move to the types of landslide. Here I have classified 3 different types of landslide according to the depth of the surface to carry out the statistical analysis to find the relationship between landslide and the each and every factors. So surface side, I have defined if the depth of the slip surface is less than or equal 1 meter, those are we have classified as surface slide. So if the depth is between 1 meter and to 10 meter, Those are we have considered as shallow slides, and if the depth is greater than or equal 10 meter, we have considered those kind of slides are deep slides. So yeah. So when you see the statistical distribution, you can see if you see the number of surface slide and number wise, it is bigger than these slides. But when you look at the total collapse area, so the total collapse area for the deep slide is somewhat like greater than surface slide. So hence, instead of the number of landslide, this work considered the landslide occurrence ratio to find the correlation between the geological and geomorphological factor in earthquake-induced landslide around this area. So now let's see the definition of the landslide occurrence ratio. Simply, the landslide occurrence ratio defined as the ratio of the collapse area to the total area. So these are the factors that I have used in this research work as causative factors. And now let me move to the results. So figure 11 shows the landslide occurrence ratio and area of the surface slide according to the slope angle. So you can see in the bar graph represent the collapse area, and the line graph represent the landslide occurrence ratio. So the surface side occurrence ratio, you can see increases with the slope angle. Now let me move to the shallow slides. So according to this figure, 66% of the collapse area of the shallow slide is occupied by the slopes between 25 to 35 degree range. And now let me move to the deep slides. You can see when you look at the this figure, almost all the deep slides occurred at the slope angle greater than 20 degrees. So now I would like to move our second positive factors. Actually, the importance of slope face orientation in the occurrence of landslide is still confused. Some researchers consider slope aspect as one of the most important predisposing factor for landsliding. But however, others limit the importance of slope aspect to certain type of landslide. So in this analysis, we investigate whether the forward direction affects the stability of the slope. So surface side occurrence ratio for slope aspect classes are represented in the figure 14 with the fold direction. You can see this, I have represented the fold direction is from this line. So you can see surface side mainly occur in southwest, south and southeast facing slope. And if you move to the shallow slide, so the occurrence ratio shallow slide is greatest, highest on southwest facing slope. And however, this trend is moderate, and the change in LOR with the direction of the slope is continuous. And yeah, when you move to the deep slide, the figure 16 shows the occurrence ratio of deep slide is higher for east facing slope. However, the results indicate that the direction of the fail slope is almost perpendicular to the fall direction, and the relationship between the direction of the slope and the deep slide occurrence ratio is very strong. And when you come to the bedding, influence for landslide. Actually, the geometrical relationship between the bedding altitude and terrain geometry are crucial to understanding landslide distribution. So it is not easy to obtain the information from the directly from the bedding altitude for large area because it's time consuming and research in intensive field surveys required. So in this research work here, we have proposed methodology to find the relationship with bedding altitudes and terrain geology. For according to our proposed method, we have classified the slope type according to three slope types. Those are deep slopes and reverse deep slopes and the horizontal deep slope. From the proposed, according to that, according to these three slope types, we have analyzed the landslide occurrence ratio And also in this, you can see in this figure, I have considered the pre-existing landslide of the area, because the pre-existing landslide have greatly changed the slope morphology and the strength properties of the ground. So that's why here I have considered the pre-existing landslide in addition to the bedding plane. So this figure shows the deep slides are more prone to occur for deep slopes. Yeah, we can see the purple color line. But the occurrence ratio for pre-existing landslide is also higher. And let me move the distance from epicenter fault line. Now let's see the relationship of the distance from epicenter fault line to landslide. Surface slide and shallow slide shows the monotonically decreases monotonically with the epicenter fault line, but deep slide does not show that kind of clear relationship. And when you talk about the water bodies, so to examine the effect of water level for occurrences of landslide, we assume ground level was very high near the water bodies such as rivers and ponds. So this figure shows the variation of landslide occurrence ratio as collapse area with distance from water bodies. It is very clear most of the landslide located very near to rivers and ponds. And now let me move to the conclusion of. So here we have the surface slide occurrence ratio greatly increase with the slope angle, but deep slide and shallow slide do not show a continuous increase. Surface slide and shallow slopes that face parallel to the fall directions are more prone to failure. However, the trend is moderate and the change in the LOR with the respect of direction of the slope is continuous. The deep slide occurrence ratio is higher for slopes that face perpendicular to the fall direction because the obtained relationship is strong. It can be concluded that the deep slides are strongly affected by geological structure, and the shallow slide and surface slide occurrence ratio are more or less equal for all slope types, I mean the bedding planes. This results indicate that shallow and the surface slide occur independently of the macroscopic structure of the slope. So these are my references, and thank you very much. So if you have any question, yeah, please ask, and I'm happy to help you. And thank you very much.